Okay, 6-1.
Oh, wait, what?
That's awesome.
Wait.
I know, I literally watched the old movies.
Come on. No salt. Let's get moving.
I like the dinosaurs.
Yeah, I watched one of those up until like 9.
I always, now I'm kind of sick with like the marketing stuff because it's pretty close to me.
Yep.
The music, that's the most fun. And the ones that you know.
I love this movie. Like, I watched Frozen 6 times since I got it on Sunday.
I never stopped watching it. It's sad that you don't get bored of it.
Okay.
Yeah, it's like median, variance, and standard deviations, different parts for us to fit that.
Yes. Okay, what the last chapter did was we knew something about the population. They knew what the mean and variance and standard deviation was, and then we did a sample and found probabilities of that sample being in this window. What's happening here is we're reversing the process. If I don't know something about the population, I can use a sample to tell me something about the population. You see a lot of this at election time. Like the presidential election, they'll tell you with only 3% of the vote in a state which president has won that state based on the sample. They don't need to tally all the votes to tell. All they need is a small sample and they can estimate what's going to happen. And that's what this chapter is all about, using a sample to estimate something about the population, which is actually quite powerful stuff. So, what we do is we start with what's called a point estimate. A point estimate is a single value estimate. I should say a single value. Okay, so it's a single value. In this section, we're going to be estimating population mean. So, for the mean, for the population mean, which is mu, the best estimate, single value estimate, the best estimate is obviously, or maybe not obvious to you, the sample mean, X bar. And when we do this, because of that central limit theorem, our sample must be what size? Central limit theorem said how many do you have to have in the sample?
30.
Greater than or equal to 30. Okay, so what do you think the chances are that if I took, let's say I wanted the, come on in, the average IQ score of the kids at Gladstone High School. Okay, so I take 30 kids, average their IQ scores. What do you think the chances are that my average of 30 actually hits right on the head the population average of everybody in high school? Not likely, but is it going to be pretty close? Probably, because of the central limit theorem, because it narrows that graph up so much. The chance of hitting it right on the head is very slim, but having it be pretty close within a range, yes. So our whole goal today is to do a range. So, what we move into is called an interval estimate. Yep. So this whole chapter is going to be about interval estimates. So what we're going to do is give a small range of values that I think the population is going to fall in between. Then I've increased my chances of actually getting the right value. So an interval estimate is a small range of values used to estimate the population value. Okay, so there's a lot of vocabulary before we actually get to the process. The process is pretty easy. Okay? So before we can actually do an interval estimate, we have to talk about our level of confidence. Yes. Low. Yeah. Ashley said low. So level of confidence, which we're going to use lowercase c for, is the probability that the interval actually contains the population parameter. The probability that the interval contains the population value. Okay, the most common levels of confidence used, 90, 95, and 99. Not the only ones, but those are the most common if you're doing statistics. Everybody got this but Iris? Jake, you got it? Hand this off to you. So, most common levels of confidence, 90%, 95%, and 99%. And remember, what we're talking about is our sampling distribution curve. Confidence. And what we're going to need are z-scores. So I'm going to make a little table here. So our confidence level what we're going to imp norm, and then the actual z-score outcome. Because when we do these confidence levels, we're doing the middle 90%. I'm 90% sure that my population mean is going to be in this chunk, or I'm 95% and I make my interval a little wider. So, yes, that will never go away. So if I do a 90% confidence interval in a minute here, that means that I'm 90% sure that the population mean falls in between here. There's a 10% chance that I didn't contain it. Okay, but what we need are these z-scores. And we know that they're symmetrical. Then we just use the positive one. So this is a good review from yesterday. If I'm doing the 90% confidence level, how do I get, say, this negative z-score? What do I imp norm? I heard it. 0.5. I forgot to divide it in half.
Anastasia Martinez, Isabella Matthews, Lindsay and Megan McCann, Chelsea McDonough, Lacey Mitchell, Ryan Bertha, Brittany Knauss, and Betsy Olson. Please report to the gym at this time. Thank you.
So if you imp norm 0.05, because that's what's going to be over here, that will give you the negative z-score, but we're just going to use the positive one. So what does that come up? Anybody? Imp norm 0.05? Because there's 10% left. I need the area behind this value. And there's 10% left, and that's 5.
1.64.
Okay? And the book, if you want to match, uses, and we're going positive, 1.645. I have no idea why. They're going 3 places on this particular Z-score, but they are.
They do it all the time? or not?
Yep, all the time. So if you want to match, just get in the habit of using 1.645 for 90%, because we always use the positive in the formula,
What formula?
the one that's coming. Okay. For 95% confidence level, that means I'm going to widen my interval out a little bit. So there's a better chance that I've contained the population value. Now I've got 95% in the middle. What does that leave in this one tail piece? 0.025. So we're going to IMS norm 0.025. And this one goes out 2 places. Andrew, what'd you get?
1.96, or actually, well, 1.96 though.
1.96. 1.96 is what they use for the 95% confidence interval. And then the other most common one is to go out to 99%. And we ran out of room there. So you just keep widening your interval. What do I have to IMS norm to get that Z-score? 0.005. And that's what? This one goes out 3 places too. They use 575. Is it 576 on there?
Yeah.
So that's what the book uses. If you don't, it's okay because you're going to show me work anyway. It'll be slightly off from the answers I read or that are in the book. Okay. Will they always be these 3? No. Every once in a while they'll throw in an odd duck just to see if you remember the process to get the right Z-score. So you need to know what's in your tail piece and you IMS norm that and then just take the positive of it. Okay. So, here we are. We're working our way to finding a confidence interval. We have to find max error. Maximum error. Also called error of tolerance. It tells you the farthest away from the actual mean you could be. So it gives the maximum distance from the population value for a given confidence level. And max error formula is very easy. Yep. It is the Z-score for your confidence level, which we just did in the table, multiplied by the standard error of the sampling distribution. How do we get the standard error of the sampling distribution? You just had a test on it yesterday. There it is. So it's Z-score times standard deviation divided by square root of the sample size. And what's allowed to happen here, because this is an estimate, most often we don't know this population value. Remember, the information about the population isn't known, so we're using the sample to describe it.